Sam wants to know how many candy pieces she eats in an hour. She created a graph. What is this graph called and what is it used for? So, first off, this question, we can establish it. Sam wants to know how many candy pieces she ate in an hour. In an hour, it's not going to go over an hour because that's not what the question established. So first the candy pieces, and this is the minute per hour. This is called a data table if you were not already aware. So she ate 6 candy pieces in 15 minutes, 12 in 30 minutes, 13 in 45, and 16 in 60 minutes, or an hour. This graph, we don't know what it's called. Just ignore this, please, because this isn't the answer. So this graph, we don't know what it's called. Let's say we don't know what it's called, correct? Well, we see here, these are bars, and we can tell that this is comparing the values of candy and minutes. So we can see this is called a bar graph, and it is useful and is used for comparing values, such as minutes to candy. Now, this bar graph is accurate because it's not inaccuracy, as you may have seen before. This states 30 minutes is in for 12 candies. If this was down here all the way at 4, that's not accurate. And if it was up here all the way at 16, that's not accurate. Maybe if it was like just a little off, maybe like that, or like maybe just a little off like that might get marked down, but like it's not the most accurate you could have, but it's decently accurate where it's not like you can tell what it is, if you have the data table at least. So they're all different colors so you can, see the difference between them. But we're going to go down to the questions now. What is the independent variable in this equation? Well, the independent variable is what? It's getting changed by the researcher, which would be the minutes, because the minutes are getting changed. Just the candy's getting changed. Sure, but if you look back at the question, that's what the dependent variable is, which is what we're collecting data on, because it specifically asked how many candy pieces she eats in an hour. Well, so the dependent variable will be the candy pieces, because she wants to know how many candy pieces she ate. It's not how many minutes it took to eat a certain amount of candy pieces. That'd be a whole different problem. And there's many different types of graphs. There's line chart graphs, pie charts, and bar graphs. There's more than that, but those are the main ones. A line chart or a line graph, it basically just shows you, they're useful for showing the changes over time. The pie charts are useful for showing percentages of a whole, and then the bar graphs are useful for comparing values. They all look very different. I can show you a photo. This is a line graph, what you would see in the office workspace maybe. Sales have gone up, sales have gone down, maybe even like rain check. Then the pie chart looks like this. You'd probably see that like some population of the world. What population of the world eats hamburgers? USA. There's more examples, but those are the main graphs and scales. And some tips for graphing in the data tables to make sure you're correct and like that you have all the stuff to make it, and so you wouldn't get marked down or be less accurate. So it's called SULTAN. SULTAN stands for scale, units, label, title, accuracy, and neatness. So if we look for the scale, this is the scale. Normally it feels like a line graph. It has lines across it, and that's the scale. Or in this case, it's this right here, showing how high and how low. The units would be our numbers right here, 15, 35, 8, 6, 42, or 42, oops. And the title, we always need title and labels. We need labels, like right here we'd have candy pieces and minutes per hour. But I just wanted to get the basic steps to you, but that is what you need to make it, or you would get marked down. Then we have our label for this would be amount of candy eaten in an hour. Amount of candy pieces eaten in an hour. It's just straight and simple. You don't need it to be like descriptive, like the amount of Jolly Ranchers ate in an hour, or like you don't need that. It'd normally be candy, like just in general, but it could be in some situations. But also you don't want to do swip swap where it's like the independent variable is on the wrong side of the x-axis or the y-axis, like they're swip swap. You don't want that, or that'll make the equation different, because it's not the amount of time it takes to eat 16 candy pieces. It's like how much I ate in an hour. So those are totally different questions. You also want to know the accuracy, which is what I talked about earlier. Like you don't need the 15 to be all the way up here, and you can tell that is, you don't need the 6 to be up there and realize that is not right. That is totally off. Or if it's down there, it's totally off. But maybe if it's like in this specific area, it's not exactly on the 6, but it's not too bad. Like you can tell, you might get marked off, or it might get bad accuracy, but for the most part it's there. And then the neatness, this is being neat, like right here, all neat, but like on pencil might be a little hard, drawn all over the place. You don't want that, you will get marked down. So basically that is what we talked about today. The independent variable is the variable was being changed by the researcher. Dependent is what was the data being collected. Bar graphs are useful for comparing values, and data tables are very important and can relate to graphs. Hope you enjoyed this video and learned a lot. Bye!